All right, so we have this roller coaster loop, and I don't even know if I chose realistic heights, but I'm very excited to do this problem. Okay, so we're going to use conservation of energy to get the speed of the roller coaster at the top of the loop. Meow. So we have all of this gravitational energy here at the top of the hill, and then at the top of the loop, notice we're moving and we have height. So when I set this up, I'm going to end up getting EG equals EG plus EK. And so let's plug in some numbers. I'm going to have M times G times H equals 1/2 mv squared plus m times g. And let's be careful. Our height here is 2 times r. So we'll be careful with all of that. Now, I should have given you a mass. We'll use the 500 kilograms in the part below. So we'll get 500 times 10 times 250 equals 1/2 times m, which is 500, times v squared, there's our unknown, plus 500 times 10 times 2 times r, which is 25. So we've got a lot to simplify there. So when you do simplify it, you should end up getting v equals 63.25. And in parentheses, I'm just going to write, please finish, because I want to see you actually obtain this on your own. So that's going to be the speed. Now, we want to know the normal force on the roller coaster at the top of the loop if its mass is 500 kilograms. So a lot of people thought the normal force should be 0 at the top. That's only when you're at the minimum speed to make it around. If you go faster than the minimum speed, which you are here, let's be careful. We've got the normal force and the weight pointing down. So we're going to have normal and Fg. And the effect of these two forces is that our roller coaster is going to have centripetal acceleration going around a circle. Continuing, we're going to say normal plus 500 times 10, because Fg is m times g, and the effect is going to be 500 times v squared, which is going to be this 63.25 squared, divided by our radius, which is 25 meters. And so when you actually solve, I'll need you to do this math, so I'll write, please finish. Not to be mean, it's just, I want to start getting you a little bit more independent, not needing to see every single tiny step laid out. And even those of us who struggle a little bit with math, I've seen what you can do over the past 6 months. I really do know that you're able to do this. So I ended up getting about 75,000 newtons. All right. Now it says, what is the speed of the car at the top of the loop if the normal force in the car is equal to its weight? So what we'll do for this is we know that the weight is 500 times 10, which is 5,000. So we'll take a similar route. We're going to say that if n also equals Fg, what we're going to end up getting is 5,000 for the weight. Sorry, let me write out the full equation. N plus Fg equals, and then we'll end up getting 500 times AC, which is v squared, divided by 25. So that's going to be 5,000 plus 5,000 equals 500. Sorry. Sorry, I just don't like what that happened there with that thing. I'm just going to kind of get rid of that. So we'll get 500 times v squared over 25. So we'll end up getting 10,000 equals 20 times v squared. And when we isolate v, we'll actually end up getting 31.63 meters per second. All right. And then for this last part here, I've given you kind of a multi-step process for getting the answer. And I'm going to go ahead and kind of get you set up with each part. And I'm going to let you kind of work on bringing it home to the correct answer. But I do want to make sure that you at least have it set up to get it going and to solve it. So for this part here, we want to find the minimum speed of the car to make it around the circle. So this minimum speed to make it around the circle at the top of this loop, in this case, yes, the normal force is 0 because we're at the minimum speed. So with the first little part here, we're going to say mg makes the car accelerate in a circle. We'll plug in our numbers. So we'll actually end up getting 500 times 10 equals 500 times v squared divided by 25. We can actually cancel the masses on each side, so we'll end up getting 250 equals v squared. We'll square root each side, and we're going to end up getting 15.8 meters per second is v. Awesome. Next, it says calculate the total energy at the top of the circle. So at the top of the circle, I have a combination of gravitational energy and kinetic. And this h at the top of the circle, well, that's equal to twice the radius. So I'm going to put mg times 2r equals 1/2 mv squared. And now let's put in some numbers. 500 times 10 times 2 times 50 equals 1/2 times 500 times 15.8, plus 500, plus 1/2 times 500 times 15.8 squared. When we actually calculate this out, I'm going to end up getting a total energy of 312,500 joules. Lastly, this energy here is going to equal the energy at the very top right here. And that's going to be equal to m times g times the big height that we're solving for. I'll put 500 in here, 10 for the gravity. And so what we'll end up getting, I'm going to ask you to please solve. We'll end up getting a height of 62.5 meters. So that is the third page of the test, and we'll continue on the next page.